All right, let's start off. I'd like to start off by thanking all of you for taking the time to attend our presentation this afternoon. First off, my name is Lance Zurich, and today we're going to take a brief look at the two special curriculum-based sets from Studica that are designed for introducing students in middle schools, high schools, and homeschools to the fundamental principles behind mechatronics. Now, each of these sets are designed for conducting a project-based class, and that's where students will be required to design and build a series of original prototypes based upon their own research and their own activities. And each of these sets includes standards-focused curriculum, which was created especially for Studica by noted expert and STEM educator Tom White. So today we're going to start off where so many technology-focused presentations for education seem to start these days, and that's with the skills gap that exists. Now, when you hear someone reference the skills gap or talk about the need for better STEM education in the schools, STEM, of course, being an acronym which stands for science, technology, engineering, and mathematics. So when you hear somebody saying this, what they're essentially talking about is the urgent need to prepare our students with the background they need to successfully compete in the job market which they will graduate into. Now, in the employment market that once greeted our grandparents or maybe even our parents, a good work ethic, a strong back, and being able to take direction might have been enough to land a good paying job where many of the technical aspects could be learned on the fly. But now, students must prepare to enter a world that is increasingly focused on programming, automation, IoT, and rapid advances in all aspects of technology. So in short, students must be able to demonstrate technical literacy and aptitude if they hope to compete and succeed. Now, this is of course why so much of the emphasis in education over the last decade has been on developing STEM skills. Every new advantage that we enjoy, such as, for example, the tablets and the smartphones that I'm pretty sure all of us use every day, all of these advantages were created because of individuals who helped us to make those advances. Now, countries all around the globe, countries like China and India and so many others, are making major strides in developing new technological advances and preparing their own students to take their place in the future workforce. Now, here in the United States, we also need to prepare the next generation of graduates with the skills, the mindset, and the habits that will enable them not only to secure jobs, but to be part of the next wave of advancements that we rely on to stay competitive on the world stage and to maintain our stature as a world power. Now, as I have no doubt that anyone attending a webinar like this is already in agreement about the importance of STEM and technology-focused programs, let's now move right along to the main topic, which is, of course, mechatronics. Mechatronics has been called the science of intelligent machines. It's a study that focuses on electrical systems, control and mechanical systems, robotics, the Internet of Things, and computer science. All extremely important subject areas for students to be exposed to be sure, and all skill sets that are highly prized in today's technology-focused job market. But just how highly prized? Well, per the website careerexplorer.com, the average salary for a mechatronics engineer in the United States is currently around $96,980 per year. So while, of course, the students who go on to secure these prized career positions are the ones who prepare themselves by pursuing the proper post-secondary coursework, they need to start developing the habits and the career focus as early on as possible, in high school, if not even in middle school. The dilemma for educators, though, whether in the classroom or the homeschool environment, is finding ways of introducing this type of subject matter to students in a way that gets them interested and involved in the learning process and not just involved in memorizing obscure facts or ideas so they can take a few tests and then promptly forget them all. No. To best help students to really be successful and to really encourage them to consider pursuing further education in subject matter such as this, educators need to be able to present the material in a way that makes it relevant, which means, of course, answering the eternal student question, why do we need to know this? And it also needs to be engaging in a way that holds students' attention much better than rote textbooks and lecture presentations. And it has to be something that has real, visible, real-world applications in which the students can get involved in doing things hands-on. Now, it is with this dilemma in mind that we created the Studica Mechatronics programs. These two special sets, one of which was designed as an introduction to the world of mechatronics, and one of which is intended to be essentially a standalone class dedicated to the subject matter, were created to provide all of the materials in one place that educators would need to enable them to offer a project-based class that is relevant, engaging, realistic, hands-on, and which is crafted to meet the most current academic standards in place. Each of the two Studica Mechatronics program sets comes with its own detailed day-by-day curriculum document, which was created especially for Studica by noted educator and STEM expert Tom White. The curriculum comes as a downloadable PDF, which is available for free with the purchase of each set. This curriculum is designed to align to the most widely accepted academic standards currently in place in the United States. The curriculum is also designed for offering a project-based learning program. And when we talk about project-based, this means that solving the problems that arise in each unit requires the students to be actively involved in the research phases, the design phase, the trial and error experimentation activities, and also the building of actual working prototypes that will provide the required answers. And students won't do this alone. They're going to be asked to work in small groups or teams, if you prefer, of 4 students each. Now, this will help to develop the soft skills that students also need, maybe just as much as they need to develop technical skills. And of course, when we're talking about things like soft skills, we mean things like communication skills, teamwork, adaptability, problem solving, and of course, leadership. And finally, with the exception of some very affordable programming software, each set includes all of the physical building materials each group will need to enable it to address all of the design projects presented throughout the course of the curriculum. The curriculum is designed to enable educators of all backgrounds, and this means even teachers from non-science or non-technology focused disciplines, to allow them to have the information they need at hand to properly prepare them for conducting all of the activities, and also to increase their comfort in presenting the material to their students. The curriculum is designed to be easy and clear and easy to follow, and to provide a clear roadmap for student learning. Various supplemental materials are also included, both in link form throughout the curriculum and also at the end of each unit. And there are also special tutorial sections on familiarizing students with the building system they're going to be using, and also to address the various projects presented in each of these units. The units in the curriculum are designed as a series of projects. So each of these projects is presented to students in the form of an engaging real-world style scenario where students must work together in small teams. Again, these are teams of 4 students per group to create a solution to this problem. The project units each contain embedded academics. At the end of each of these units, students will be required to make a formal presentation of the prototype they have created to address that particular unit's real-world scenario, and they're going to have to explain the reasoning behind the way they constructed the prototype. There is a technical literacy task driven by each of these projects. As students work to address each project, they're going to acquire the knowledge they need through inquiry and exploratory research. Science, math, and technical skills are acquired throughout the carefully designed enabling activities. Again, as required by each project, students will be asked to create original prototypes along with any programming-based solutions that may be required depending on the project, and also to maintain detailed documentation during the entire process. Now, as I mentioned a few times in this presentation, the curriculum that accompanies each of the Mechatronics program sets was created especially for Studica by a man named Tom White. And you see Tom here on the screen. Tom is a noted educator who's been involved in teaching STEM and technology since the 1970s, and he's known for designing programs both for educational institutions and for industry use. In fact, as an expert in hardware and software integration, Tom has been pivotal in introducing subject matter like CAD, CAM, control systems, digital control, additive manufacturing, and other such topics to the classroom. Now, currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. The standards addressed in the Studica Mechatronics programs are the most widely accepted standards currently in place in the United States. These include the college and career readiness standards for mathematics, reading, and writing, as well as the next generation science standards for K-12 and the standards for technological literacy. As I mentioned earlier, the programs are designed to be project-based. And when students ask, why do we need to know this? It's usually because the subject matter they're being presented with might come across as perhaps too abstract or to ever be useful in their lives and just not relevant. Well, with this project-based approach, students get to see firsthand why these things are necessary and where they're useful. The concept of working in the small groups to solve these project problems also helps students to develop the high demand soft skills that employers look for. Again, things like communication and analytical skills, quantitative skills, flexibility, adaptability, and problem solving. Now, in this project-based format, all of the subject matter is integrated. And what this means is essentially things like the math is integrated with the reading and the writing and so on, which is really an ideal way to present STEM education. Also, because of the manner in which students must approach each of the projects being put forth in the curriculum, once again, with the research and the testing and the group give and take, just to provide a few examples. With this approach, it allows for a much deeper exploration of problems than traditional teaching methods might normally allow. The projects presented in each unit are also designed so that if you have several groups working on the same project, you should see variations in their prototypes and, of course, in their solutions. Now, this can be because of creativity differences or differences in research and approaches taken by each group. But in any case, students get to see firsthand that problems can have many different answers and that often there is not only one right answer. Each project in the curriculum presents students with the opportunity to plan, to organize, and conduct research. The enabling activities that students are asked to engage in provide them with the skills and knowledge they will need to draw on to complete each project just in time. And students will be required to do extensive research as they complete these projects, research that is utilized in the design, the prototyping, the testing, the evaluation, and the redesign phases of each of these solutions. And once again, the Studica Mechatronics sets are designed specifically for students to work in groups. Each set contains enough materials for teams of 4 students. Now, this team approach, as stated before, helps to promote soft skills such as communication, the ability to work well with others, and leadership. And the sets offer an easily scalable approach. Just divide the number of students in your classroom by 4 to determine the number of sets needed for each class. And once again, everything you need to conduct the program, with the exception of the programming software, as I mentioned before, is included inside of each box. Access to the free curriculum download is included with the purchase of each set in whatever quantity. Also included are all of the building materials which students will use in the creation of each of their prototypes. Now, these materials are from the unique Fisher Technic building system, and among the components included in each set are 2 robotic control units and power supplies. Now, of course, many of you may not be familiar with Fisher Technic, so please allow me just a minute or two to provide you with just a little bit of background. Now, Fisher Technic is a flexible and innovative construction system. Unlike other popular construction sets that are designed to simply stack, Fisher Technic was created with more of an engineering mindset. The core building block in the Fisher Technic system is unique in that it allows attachment from all 6 sides, and thus it allows for almost limitless design possibilities. Now, many of the parts are designed to slide together and lock in place using a tongue and groove assembly method. The system also includes a wide selection of very specific parts, various types of gears and girders and sensors and so much more, and this will allow technical builders to address equally specific design needs. Fisher Technic was developed back in the 1960s by German inventor Arthur Fisher, who's also noted for countless innovations used in the construction and the automotive industries. Mr. Fisher, at the time of his death in 2016, had amassed more patents in his name than Thomas Alva Edison had collected during his own lifetime. Now, besides Fisher Technic, Mr. Fisher was also the inventor of synchronized flash photography back in 1949, as well as the creator of the expanding nylon wall plug, which of course many of us have used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fisher Group, employs thousands of workers worldwide, producing many variations of fastening devices used in building construction, as well as components used in the automobile manufacturing process, and they are also known for providing consulting services related to automated processes. With that all being said, let's begin looking at each of the two individual sets. And we'll start off with the Studica Introduction to Mechatronics Program set, or for those of you who like to use acronyms, you can refer to it as SIMP. This set is designed to help provide a well-rounded introduction to the core concepts of mechatronics. Each set includes access to a free download of a 242-page curriculum document entitled Mechatronics Fundamentals, written by Tom White. You see the cover on the screen right now. The curriculum contains enough activity materials to fill approximately 45 academic hours. Now, as such, we recommend this program set for insertion into regular related class activities, for use as a short class unto itself, or using it for an after-school program, or of course for homeschool use. The curriculum created for the set is again standards focused. Again, this means using the academic standards most widely recognized in US-based education today, and it's designed for offering a project-based program. The set is designed for use in middle and high school classes, or again for addressing those grade levels in a homeschool environment. The set contains a collection of over 700 Fisher Technic building components, and again, this will be everything from gears and wheels and axles to blocks and sensors and much more, as well as 2 robotic control units and 2 power supplies. Again, only the required software, robotic control software, which we will discuss later, is not included, but again, it is very affordable and it's available separately. The curriculum for the Studica Introduction to Mechatronics Program set consists of 6 project units, and they are as follows: sketching and documentation, simple machines, mechanical systems, basic electricity, the conversion and storage of energy, and an introduction to control systems. There are also activities included to address the following topic areas that come up during the course of the curriculum: sketching, linkage diagrams, schematics, Ohm's law and power, pneumatics, flow charts, using software and robotic controllers, working with sensors such as the digital switch and the digital photo transistor, working with open loop or closed loop programming, working with digital branching, and analog sensors such as the photocell LDR, working with analog branching, and then onto more analog sensors, the NTC resistor and the potentiometer. Now, before we go further into the actual structure of the curriculum, let's first take a look at what's covered in the second set. And this would be the Studica Teaching Applications of Mechatronics Program set. In this case, the acronym for it would be STAMP. This set is designed for those educators and homeschoolers who wish to provide a more in-depth exploration of the fundamental aspects of mechatronics. This set comes with access to a free downloadable 400+ page curriculum document, in this case entitled Mechatronic Applications, again written by Tom White. The activity materials in this curriculum document, when used in conjunction with the contents of this set, is designed to fill approximately 180 academic hours. So essentially, we're looking at 4 times the amount of academic hours as were covered by the previous set. Now, as such, this can be seen as a more expansive version of the material touched on in the previous set, and it's also designed for those educators who are able to dedicate a daily class period of approximately 50 minutes per day, 5 days a week, or the equivalent, every week for a full school year. Again, this set is designed for offering students a standards-focused, project-based learning experience and is designed for use in middle school, high school, or for addressing similar grade levels in a homeschool setting. The materials in this set consist of a selection of over 1,200 Fisher Technic building components. And once again, this will include a wide array of gears, blocks, sensors. You'll have axles, so many other cool pieces, as well as 2 robotic controllers and 2 power supplies. And once again, the software is required for this set and it's sold separately, and we will of course touch on that at the end. Now, there are twice as many project units included in the Studica teaching applications of Mechatronics program set as with the previously discussed set. This will include units on sketching and documentation, simple machines, mechanical systems, basic electricity, and then project-focused units on the creation of a garage door, an elevator control, an automated pneumatic clamping system, an automatic pneumatic feeder system, a conveyor with a counter, a robotic control, a sun tracking solar panel, and a color sorting machine. And again, during the course of the curriculum, links are provided to tutorial sections and activity materials for students to utilize. And this will include sections on sketching, linkage diagrams, schematics, Ohm's law and power, flowcharts, using the programming software and robotic controllers, working with open loop programming, working with sensors such as the digital switch and the digital phototransistor, working with closed loop programming, digital branching, logic gates, combinational logic, edge triggered versus level triggered, pneumatics, variables, positions, recording positions, creating a graphical user interface, working with analog sensors such as the photocell LDR, the NTC resistor, and the potentiometer, and working with data. Now that we've had now that we've had a look at how each of these sets differs, and of course the specific subject matter that's being covered with each set, let's now look at exactly how the curriculum itself is structured. Now, both versions of the curriculum share the same essential format when it comes to the structure of each project unit. And as already discussed, each version will include tutorial materials, activity materials, standards, and supplementary materials. Now, in each case, the curriculum is designed to be turnkey. And what I mean by that is each unit is designed to clearly spell out everything that's being addressed, and again, to provide tutorials and other information as the topics arise. Now, this was done specifically to enable teachers from all kinds of backgrounds, and this means including those teachers, again, who come from a non-science and a non-tech focused background. It was designed to help make those types of individuals quickly comfortable with delivering the material simply by reviewing each section before you present it in class. So what I need to state again is, once again, you don't have to take a class to learn how to conduct this material. You don't have to go through a training. You don't have to ship off somewhere. Basically, if you spend time with the material before you present it in class, it is designed to answer hopefully most of your questions. Each unit presented in the curriculum for each of these sets includes the following sections: an introduction, the purpose of the project, the concepts being addressed, an outline of the material, the standards that apply, the assessment rubrics, the essential question, the student scenario, again, this is the real world scenario, the daily plan, vocabulary words, and other resources. Now let's take a look at each of these sections a little bit closer. Again, the units start with an introductory section and the purpose of the project. Now, of course, as you would likely gather from that name, this is the section that provides a brief description of the topic that will be explored in the coming days and activities. And this is also the section that seeks to clearly spell out to the students why they are learning the material and why it's important for them to know. The next section focuses on the main concepts to be addressed in this unit, and these are the broad ideas that will be explored in the particular unit and the core information that students should take from this project that will be essential for them to understand and utilize not only today, but to draw upon as they move forward in STEM fields of study, and of course, if they chose to pursue it, in STEM-related careers. Following this, we encounter the outline. In this section, we drill down more specifically to what will be addressed in the unit. Now, as the example shown on the screen right now is taken from the unit that addresses aspects of programming, you will see that we will touch upon areas such as the methods for writing programs, for example, using flowcharts or word problems, working with program characteristics, for example, open or closed loop programming, working with branching, whether it be digital, analog, subprograms, and so on. The next section of each project unit will focus on the specific academic standards which will be addressed in that particular unit. Again, as you will see, this includes the college and career readiness math standards, reading standards for literacy in history and social studies, writing standards for literacy in history, social studies, science, and technical subjects, the National Research Council's Next Generation Science Standards for K-12, and the standards for technological literacy. Each project unit also contains rubrics, and this will include both rubrics for the specific project unit being covered, as well as general rubrics for literacy tests. Next up, we find the essential question, and this can be thought of as the big picture question that will be focused on in each of the smaller individual activities that students will encounter, and of course, all the aspects of the larger project which students will be asked to complete in this section. This is followed by the student scenario, and the student scenario is where the specifics of the project to be addressed are finally spelled out. This is presented in the context of a real-world style scenario where students are presented with a problem that needs to be solved with the creation of some sort of a device or a machine or a mechanism. Now, as I mentioned before, students are not going to be asked to do this alone. They must work together in small teams to craft their answers to this challenge. Solving this problem will require each team of students to design a unique and original answer, which once again will be usually in the form of a working prototype, along with whatever programming might be required. Now, just to provide an example, if you look closely at the student scenario showing on the screen right now, you will see that in the project in this unit has each group of students taking on the role of a design team employed by a firm that manufactures garage door openers. Now, in this particular case, students are being required to design a specific type of control system for a new line of garage doors. The manufacturer's requirements are all spelled out here, such as in this case, the use of limit switches, meeting certain safety codes that require a method for sensing if anything's in the way of a closing door, and also the incorporation of an automatic light. Now again, each team of students will be tasked with creating both a unique and an original prototype, and in this case, it's of course the garage door opening system, as well as the programming needed to control the prototype. Now, as the students move through the challenge being put forth in the scenario, each of these student teams will be required to document the entire process in both a design notebook and a digital engineering journal. Again, noting all of the research, all of the trial and error experiments, and keeping copies of all design sketches and revisions, as well as anything else that might come up. Now, at the end of each project unit, each team of students will be required to make a formal presentation in front of the class, during which they will be asked to demonstrate their prototype and programming in action, much as they would be required to do for an actual employer or client in the real world. After this, the next section we encounter is the daily plan. And this is the section that clearly spells out, both for students and teachers, what will be expected of students, how will the teacher conduct the day's classroom activities, and what specific subject matter is going to be covered. Now, some days may involve discussions, others may involve research, or perhaps even building small projects that help provide the building blocks that students are going to draw on to complete the larger projects as described in the student scenario. Now, in short, you can kind of think of the daily plan as a roadmap, and it's designed to keep everyone on the same path. Now, you will see too that along the way, as different aspects are addressed in each day's activity, such as, for example, what's required in a design notebook, or how do you use the control software, how do you use the controller, or how do you work with flowcharts. In any case, there are links to sections which will provide further instructions and information on each of these areas as they arise. At the completion of each unit, after the last day of the daily plan, is a section containing vocabulary. And you can think of this essentially as important words and terminology introduced during the project unit, as well as a selection of useful resource materials. Now, these resource materials can contain a mix of different types of material. It can be everything from carefully vetted websites and video links, could be PDF documents, could be PowerPoints, can be even other things. Now, besides the project units, each of the curriculum documents also includes a special tutorial section designed to educate both students and teachers on how to use the Fisher Technic building system. Now, this includes information on how the parts fit together using the pin and groove assembly method I mentioned before. It talks about identifying the various types of parts used, from the different types of girders and blocks and the different types of axles, gears, and rivets, and so much more that you're going to encounter. And students also get to build a very basic model, sample model here, just to help familiarize themselves with the system before they move on to the projects that are being addressed in each of the units. And as learning about and maintaining proper documentation is one of the areas that we, of course, stress in the course of the curriculum, there is a section which details just what defines each type of documentation that I have listed on the screen right now, and what is going to be required from the students for each of these types of documentation. And as the process of conducting these types of more open project-based class activities might be new to many teachers, there's also a section that discusses project-based STEM education and its benefits. Now, as that completes the overview of these two sets, let's quickly review the contents and purpose of each set once again, but this time with pricing. First, we have the Studica Introduction to Mechatronics Program set, which is designed as a standards-focused, project-based introduction to the core concepts of mechatronics. Once again, it includes the highly detailed 242-page curriculum document entitled Mechatronics Fundamentals, written by noted educator and STEM expert Tom White. The curriculum, when used in conjunction with the building materials in this set, will provide teachers with enough academic material to fill approximately 45 academic hours. It is again designed for those educators who wish to offer a shorter class on this material, who want to use it for after-school programs, or of course for anyone who wants to use it for homeschool use. The teaching materials designed for use in middle schools and high schools, as well as again by homeschooling parents seeking to address STEM and mechatronics for these specific grade levels. The physical materials in this set include a selection of over 700 components, including blocks, gears, sensors, and much more, once again taken from the Fisher Technic building system, along with 2 robotic control units and 2 power supplies. These materials will again be used to construct the mechanical prototypes addressed in each project unit of the curriculum. Software is again required, and we'll touch upon that in just a moment. And I would also mention too, that in the case of all of these parts that are included in either of these sets, these are things that you can build, you work with, then you can take them apart, and all of the parts can be reused over and over again for all of the various projects, or if you chose to conduct these the same class next semester with a different group of students, you can all use all these same parts and what have you. Everything is reusable. But again, each set is designed for use by teams of 4 students at a time, and the pricing starts at just $699 for a single set. And I will add, discount classroom pricing for groups of 20 students and up is available by quote upon request. Next up is the Studica Teaching Applications of Mechatronics Program set, again stamp. Once again, this is designed as an in-depth, standards-focused, project-based exploration of fundamental aspects of mechatronics, which is based around a highly detailed 401-page curriculum document entitled Mechatronic Applications, written by noted STEM expert Tom White. Now, when used in conjunction with the building components included in this set, the curriculum is designed to provide enough activity and material to fill approximately 180 academic hours. Now, because of this set is designed specifically for those teachers and homeschoolers who are able to dedicate a daily class period of 50 minutes a day, 5 days a week, or the equivalent to this subject for a full academic year. The set is designed again for use in middle schools and high schools, as well as by homeschooling parents seeking to address STEM and mechatronics for these particular grade levels. Each box contains an assortment of over 1,200 components, again taken from the Fisher Technic building system. And again, this will include an assortment of various blocks, girders, gears, sensors, axles, and all sorts of other cool things, as well as 2 robotic control units and 2 power supplies. The required software is sold separately. We're going to touch on that in just a second. Now, once again, each set is designed for use by teams of 4 students, with pricing for a single set starting at only $799 each. And once again, discount classroom pricing for 20 students or more is available by request. And as I've mentioned, that software is required, and I've touched on this a couple times. Let me address that real quickly as well. The software being used here is going to be Fisher-Technic RoboPro software, which is graphic programming software. Now this means that it uses a flowchart style design where various icons are used and students arrange them in a flowchart style manner to create the programs being used for each model. Now, the nice thing about graphic programming software is it's ideal for teaching the fundamentals of programming to users of all levels. So it's very user-friendly, but it also teaches essential concepts that are used in all sorts of programming. Pricing for a single unit license is only $36 each, single student license, and unlimited school site licenses, meaning that you can have unlimited users in a single site or building with this license, whether it's one computer, 100 computers, 200 computers, whatever. As long as you're only using it at a single site, your cost for the site license is only $120. And please note that these are not subscription prices. They are not annual licenses. These are non-expiring licenses that you can access and use as long as you have the software disk which comes with each of these and are able to install them on a compatible Windows-based desktop or laptop computer using Windows version 7, 8, or 10. So on that note, if there are any questions, this would be the time to use those chat windows and question and answer windows that I mentioned at the top of the program. Once again, you can find the chat window, I believe under the ellipses. The question and answer window should be halfway on the Zoom toolbar. So if you just click on the Zoom toolbar, it should be at the top of your screen. You should be able to get those to show up. So if you do have any questions, I will do my typical going once, going twice, just keep things moving along. I will move on to the next screen and provide you with some information in case you're ready to take the next step. If you'd like to request a quote, or if you'd like to speak to the dedicated educational representative for your particular state to find out more about these two sets, or any of the other educational solutions we offer, including a whole line of Fisher-Technic education-based solutions for teaching STEM and robotics and all sorts of great subject matter. If you want to find out about any of this, you can simply call us toll free, and the number is 888-561-7521. Or if you prefer, you can also email us at info@studica.com. Right up on the screen there, you'll see it. Now, if you have any specific questions about anything that I've discussed today, or maybe things that I haven't touched upon that you think I should have, or any other questions about Fisher-Technic, which I've mentioned Fisher-Technic a few times, or other things that we have available in the Fisher-Technic education line for teaching about STEM and technology, you can also email me directly. As you see, my email is right up there. It is lance.zurek, lance.zurek @studica.com. Just email me and I'll be happy to answer any questions you might have. So on that note, as I don't see anything else coming up, I'd like to thank you all very much for taking the time to attend today's presentation. And we really look forward to speaking with you soon. So we hope to hear from you. Either call us or attend another one of our webinars. But in the meantime, have a great afternoon. Thank you very much.